Hello everybody, this is Alexey Kovязин from Firebird Foundation, and today I would like to discuss 15 Firebird anti-patterns. By anti-patterns I mean things which can lead to slowness, to some problems with Firebird applications, and things which are often implemented by Firebird applications developers in the designs of their applications. Let's see them. I decided to start with these 15 anti-patterns because they are really frequent. In our practice, I see a lot of situations when the developers make these mistakes and implement these features in the way which affects the Firebird performance and other things. So let's see, and the first anti-pattern which I would like to explain is multiple parallel queries to monitoring tables. It is a very popular mistake, very popular situation when the developer implements in the onConnect trigger some query to the monitoring tables. For example, many developers want to implement audit. So at every connection, when the connection is being established, they want to log into some table data from the mon attachments monitoring table. And for this, they requested and extract this data from monitoring tables and write to some table or to other destination like log file. However, this is not really a good practice. Why? Because the monitoring tables is a virtual tables which actually store it in the special files. We call it FB mon files. You can see them in the C program data Firebird in Windows or in TMP Firebird on Linux. And there you can see the size of these files. And if you see that this file is greater than 1 gigabyte, it means that the monitoring tables are being used too intensively. Why they can be used, too intensively? The idea of monitoring tables is perform some administrative tasks. They are not designed for usage in all or in many parallel connections. If there is one or two administrators tools which request monitoring tables with some interval, it is fine. Firebird will create monitor structures to hold monitoring data and supply from these structures the one or two or three administrative connections. But if there is a parallel connections, the load on Firebird to maintain the monitoring data becomes too high, and it becomes very noticeable even on the powerful servers when you have around 200 connections, and it becomes progressively slow. It looks like the crowd of administrators tries to monitor all the information, and result is pretty bad. We have seen situations when the pretty big server with 500 connection looked like being completely frozen due to too many monitoring tables queries to the monitoring tables from onConnect triggers. So this is really, really bad. From Firebird point of view, it is much better to use these monitoring tables only for administrative tasks and the special tools which will give you some information from monitoring tables to see which connection consumes a lot of data, performs a lot of page reads, page writes, and so on. But do not use it for administrative tasks like audit or counting of connections for the license purposes, for example. First of all, there is a context variables which contain data like current user, current timestamp, and so on, which can be used instead of querying, monitoring one attachments to get this data. So use them. It is really fast and convenient way to perform, to log the activity of users, for example. If you need real audit, use the native audit based on Trace API in Firebird. It was designed specifically for it, and it's really good, lightweight, and nice tool. If you are using some monitoring tables, trying to use monitoring tables to count the license, also it is possible to use context variables as a solution, or use some another approach, not through the monitoring tables. The second anti-pattern is loading dashboard information. By dashboard, I mean some dashboards or scoreboards which demonstrate some kind of summary information. For example, in this on this slide, you can see that we are calculating the total sales for the whole month. And when the user opens it, it sees some nice looking numbers or graphics or something like this, which shows the overall progress of the company, or his own progress, or something like this. By dashboard or scoreboard, I mean some information which is not directly required by the user to perform the task which he needs to do. If he is paid to create invoices and he will wait several seconds every time when he opens the form with invoices, it will be just considered as a slow and irritating behavior, and the application will be also considered as slow, and as a result the Firebird also will be blamed as a slow database. But the problem with this is not the correct approach. The dashboards and other things, they should be used correctly. From Firebird point of view, there is this situation looks like there are a lot of constant parallel queries, very similar to heavy reports, because they read a lot of data for the 1 month. In some bad situations could be 1 year, or from the beginning of the database. And these amounts with lots of data are needed to be processed. So it consumes a lot of CPU, disk, and also it consumes cache. By it constantly kicks out the data which is necessary for the real job, for the creating invoices, for the searching customers, and so on, to demonstrate the same data. And every time it performs the same query. And especially bad if it runs pretty frequently, like several times per minute, and it is run for every customer, or for all users of the application, or to some big group of users of applications. What we can do? Well, here there will be solutions from the easiest to more complex one. The first one, of course, is just decrease the number of users who will see the dashboards. You can implement some kind of flags, show or not show dashboard, and by default disable it. If user really wants to see dashboard, he will enable it. Also, probably it makes sense to restrict it to some high management and business analyst, or to guys who are really interested in the sub numbers, because the normal accountant, he's just not interested to see the number. So it is really easy to fix. However, for the more consistent, the better solution will be to improve the overall approach, how to calculate the data for the dashboards if you really want them. The very easy approach is to calculate this dashboard's number using one process, like robot, for example, which will do it once with some schedule, like 1 minute or 5 minutes, and store it into the sum table, for example, with the latest data. And from this data, the end user application will read it with the simple select without performing the huge order by, sort by, group by, and so on. Even better could be using aggregates. So if you will implement some triggers and store data in some aggregated table, recalculate the values, so the numbers you are looking for will be immediately available. It is also could be possible to use in some regular reports. And also the solution, you can use replica for the calculation of dashboards and other heavy reports where we will not affect the operations of daily users' operations. The third anti-pattern is loading unnecessary records. As you can see on this slide, if you are open some large data set without filtering or with very little filtering, it means that every opening will load the large date table or large data set into the memory. It means that all this data will be transferred through the network. All this data should be read from the database, from the cache, and they should be kept for the future use. Usually the typical grid shows like 50 or even less records. So definitely it makes sense to limit the output of loading. And also very often users need only recent data or kind of pre-filtered data. So instead of using the select all from the table, use some filtering. Because from Firebird point of view, this situation when every connection or some form opens a lot of data looks like a heavy load and waste of resources. First of all, a waste of memory to keep everything in the memory, in the cache, and keep it in sync. The problem also that Firebird does not close the query when it is not explicitly closed. For example, if you have opened the grid and there are 1000 records as a result, in the grid you have 50 records shown. But Firebird thinks that you will or user will scroll down and it should keep all records ready. If there was some sorting, planned sort for this query, it means that records was usually was sorted and they are kept in the temp space. And temp space also has limits. You cannot indefinitely keep opening record set in memory and do not affect the performance. So what we can do? First of all, the really easy thing, which is really popular in the world of web applications, is limit records. In Firebird, there is a first skip and rows, where you can put some reasonable numbers like first 50 records or 100 records, and it will greatly decrease the burden, the load for the Firebird and memory usage, network load, and so on. Also, you can use some criteria, maybe criteria from the last user search or some basic criteria like show only recent records created from yesterday or something like this. And in general, the general recommendation for Firebird is to close queries as soon as possible. Do not Firebird keep resources to support, to keep data for the queries which were already executed, but they are waiting for the retrieval of the data. And if you will keep record set small and queries short, Firebird will be really grateful. Anti-pattern number 4 is excessive querying on scroll. For example, if you are loading some data into the grid or maybe even on the data page, and you want to request additional information for every record in this dataset. Also, the classic example could be if you are requesting the details in the master detail example, in almost every Delphi tutorial. So if you are scrolling through this grid, also will be effect of pretty large amount of small queries generated from the grid. Well, you can imagine several such scenarios when you have some record set, and while users are working with this record set, application starts to generate additional queries based on what user is seeing on the screen, like for each record. Why it is bad? In general, this query, small query for each record looks like not a really big deal. But when it comes to the large amount of users, like you have 200 or 300 of simultaneous users, and they are all open the grids, and applications start to generate multiple queries for each record. Multiple, it means like the total Firebird will receive 70 or 100 thousands of very small queries every minute. So several thousands queries every second. Of course, it is not good, because even if the query is really small and it is listed as 0 milliseconds in the performance report from Trace API, anyway, Firebird needs to perform several steps like preparation of the query, which can be not really fast depending on the tables which are involved in the query. It should actually execute queries, so allocate all internal buffers and so on, transmit through the network, return from the network, and everything. It takes CPU and it takes some memory. And even if this query is just getting some RDB database or returning in one record, when there will be a lot of such queries, it will certainly create a negative effect on the database performance. It is pretty easy to identify when you have such a lot of queries. If you are running trace and you are analyzing the frequency, you will see a lot of the same queries, repetitive queries, which represent like 70 or even 90% of all executions. It means definitely there is a problem with too often small queries. How we could solve this problem? For example, in case of grid, you cannot perform the specific query for every record, but instead you can calculate the, as it is shown on the slide, you can calculate several IDs and perform only one query with several parameters using in or something like this. In general, it is also necessary to think about the situation, how to improve it. First of all, it can be possible to enhance the main query to provide the necessary data inside the record set, inside the original record set. Sometimes it can work, sometimes it can complicate the things, but definitely it should be considered, because when the data are being processed inside Firebird, prepared and returned as the part of the one big query, it can be much faster when perform like 100,000 of small queries for 100 records, 100,000 thousand records of the main query. When really easy solution, you can change the interface of your application and add some kind of explicit button to load details for the visible part of grid. Yes, it will be not really fancy, so it will be not really automatic, but you have a button. You can click on it and get the necessary data, loaded to the grid. Also, more elegant approach, the same, you can delay this loading of this data. Instead of loading immediately when you open the scroll, delay for 1 or 2 seconds, because people can use the scrolling or something like this. Of course, everything depends on the situation, but the idea is clear. So do not perform a lot of queries unnecessary. Also, it's possible just disable this feature for some users, because not all users maybe require this information. And of course, the kind of advice, obvious advice, you should prepare queries. If you are performing a lot of small queries, for sure they should be with parameters, not with the embedded text of the parameters, but with the prepared parameters. And if they are prepared, there will be great economy on the preparation step. Anti-pattern number 5 is unnecessary automatic refreshes. The idea of this anti-pattern is really simple. So imagine that you have something to refresh, like schedule or some queue, and every application does the query to some table or to some procedure or other logic to get updated information about some process. And it is done by some specified interval. Why it is bad? From Firebird point of view, such behavior of hundreds of clients leads to the many queries at the very same time. When the query is planned, for example, to be started at every minute, usually it means that it starts at the beginning of this minute. Sometimes it is distributed for the minute, and this is a better situation, but most often the situation, that people just implement some simple timer, and once the minute starts, Firebird receives hundreds of queries, which tries to get a lot of, maybe not a lot of, but a lot of queries which tries to get the very same data. This is a combination of kind of dashboard and on scroll event. The same data, many queries, and there are could be really a lot of such queries. When we are speaking about the decreasing such load, of course, the first solution is to increase interval between queries. It's very simple. The better solution, of course, is to avoid automatic refreshes from all the clients. So you can specify only some group of the clients, or make this functionality optional and user should opt for it explicitly, or also some button to click and get updated results. So user triggered refreshes. There are some scenarios, of course, where it is necessary to receive the update of dataset. based on and it's really necessary for the business logic. In this case, use selective refresh of data. By selective refresh, it means that do not repeat the whole, the ideal solution, the whole query. The ideal solution in this case will be streaming, but it's not really simple, but it is possible if you really need to stream a lot of data and deliver changes as soon as possible to many recipients. Streaming could be the best solution. However, it is also possible to enhance the automatic refresh with events. It can be Firebird event. The recommendation is the following. If you have some trigger which performs, by the trigger I mean timer inside the application which performs the selective refresh. You can add there the condition to check if we have received event that the original data source was actually changed. The event can be produced by the Firebird trigger, which will fire event, and the application receives event and says, okay, now I really need to repeat that query. Anti-pattern number 6 is frequent record updates. Now we are going to the area of Firebird internal functioning. So the problem is the following. If you will frequently update the same record in the different transactions, it can create many record versions, and as a result, it will slow down operations with this table. What we mean by many record versions? If you have a database, I guess you have, you can check with the following command with gstat statistics specifically for some table. Here we have a good example of the following situation. So we have a table, and you can see that this table contains 4 records. So table with 4 records. And if we will look at the max versions, we will see that there is a 148 versions of the single record. The maximum length of the record chains for one of these 4 records. And the total is 444 record versions for the total 4 records. Why it is bad? You can think about it like, okay, so this is like 4 real records and extra 444 record versions, so totally it's like less than 500 records, which is just nothing. But actually not, and here the problem is the following. So when Firebird need to reconstruct and find out which specific version is required for the specific transaction, it requires a lot of reads and a lot of internal operations to find out and perform all necessary activity. And this can be really long process, which can significantly slow down the operations with this table. So instead of milliseconds, it can be up to seconds in the very bad situations. Sometimes when you have a very critical things, for example, due to development error, one record received like 1 billion of versions of this record. Really 1 billion, and I saw it in our practice. It can lead to the situation that database will look like it hanged to read this specific record. Of course, it does not mean that Firebird hanged. Actually, you will see the high CPU usage because the Firebird will try to reconstruct the record chain to identify the necessary record version. However, the longer the length of the record chain, the longer will process will be necessary to perform this operation. And in extreme cases, it can be really hours or even more, depending, of course, on the power, on the speed of your server, on the performance of your server. What we can do with it, actually? First of all, really good news for Firebird 4, 5, and so on, the newer versions. These problems was greatly decreased due to the efforts of our Firebird developers, which implemented the intermediate garbage collection. So probably in Firebird 4 you will just not have this problem, and this is, one more argument to go to the latest Firebird 5. If you are on the Firebird 2.5 or 3, you can consider as a workaround use combination of delete plus insert instead of updating the record. Of course, this is not really good and intuitive and nice solution, but it's a kind of workaround for this specific problem. So if you, during the analysis of the database statistics, will see a lot of tables with high number of with high values of max versions, you need to think why there is such a your algorithm generates so many updates of the same record. And maybe it is possible to change the algorithm, change the process of updating to fix it. The general recommendation, of course, it's always the same. Don't keep long-running writable transactions. Writable transactions, because they retain record versions for possible use. And of course, implement proper garbage collection, sweep, and so on with with other tools, which is more area for DBA. And then this video, I'm speaking more about from the developer point of view, not DBA point of view. And speaking about the transactions, the anti-pattern number 7 is using write transactions for read-only selects. The idea is the following. So if you are performing some operation, some select operation, normal select, which will not change data, it is possible to use read-only transactions. So you can specify parameters for transactions as read-only. Why it makes sense? Why it is a good idea? When you start the write table transaction, it must be written to the header page, and as a result, when you have a lot of frequent transactions, it can lead to really big amount of writes of this specific header page. And also could be some more operations for the transaction inventory page and so on. When you are running read-only transaction, you are announcing to Firebird that this transaction should be started in pre-committed page. It will not create any new versions, and Firebird use some kind of special mode to perform in a better way, to perform faster. In general, it makes a lot of sense to use read-only transactions for read-only operations from the business point of view. So if you know that you are running some select, assign to this component the read-only transaction. Firebird is one of the few databases which allows you to have several transactions inside the same connection, and these transactions can be active simultaneously at the same time. As a result, you can use read-only transactions for select operations, and only when you need to perform insert, update, or delete, you can allocate write table transaction, perform operations, and immediately commit it. By default, majority of components of drivers start read-write transactions, so write-table transactions. And if you will start to manage it and you will start assign read-only transactions for read-only operations, it will greatly improve performance for these operations and decrease the load, decrease the number of header page writes, and something more. What is also interesting to add that global temporary pages are available, so you can write to global temporary tables when you are running some query with read-only transactions, because it is read-only and it will disappear immediately after the transaction commit. Anti-pattern number 8 will be a bit different because we are speaking about the loading data approach for transactions management and so on. But number 8 is about really practical thing, using the like with parameter. The problem is the following. When you are using something like this query, select all from table where field name like parameter, Firebird will not use index. Why it will be so? The like allows wildcard search with %sign. So, and it can replace any number of symbols. That's why Firebird cannot determine in advance will the parameter be suitable for index search, and disables index search. Firebird disables index search in this situation when you are using like parameter. Developers usually work around it with explicit parameter inside the text. For example, if you are using something inside the query text, you are using where field name like Alex and %, it will be possible to use index because it starts with some symbols and after that goes wildcard. If you are using the field name like %, and when search condition, it will be not possible to use standard index. There is a workaround, let's see for it in the next slide. And if you are using the search condition with starting % and %signed in the end, also it will be not possible to use index at all. But this approach, embedding values into the text, it has own problems, and they will be discussed in number 10, anti-pattern number 10 below. How we can work around this problem with like? There are a couple of solutions. The first one, really easy. If you know that search value never starts with the wildcard, with the %, you should use starting with instead of like in this example. So if you will use where field name starting with param, Firebird will use index for the parameter, will create a plan with index usage. Also, you can make a simple trick for the reverse it in search conditions. For example, if you are using for the condition which starts with the wildcard but always end with some value, some real value, not with wildcard. So you can create a reversed index computed by on reverse. Reverse is the standard function in Firebird, and if you will use in the where condition reverse, it will use index for reversed search, and as a result this search will be indexed and will be much faster. When logically you can implement some kind of progressive search strategy. So if you don't know, will the condition be good enough to search with the condition which could be in the start of the page, on the search condition, in the end of the search condition, or in the middle of search condition, but not simultaneously. In this case, you can implement the following. First, try to search with starting with. After that, start with search with. You can do also in the frames of the same query. If reverse starting with, and if there is no results of this search, use like with without index. It will be much lower, but anyway, it will result if there will be result, of course, because any search, it does not mean what you will get result. So the idea is pretty clear, I guess. The next thing also possible that you can use word-based search optimization. So you can split the conditions. If you know that you are always searching for the word or some token, which you can split the original table. So you can make a split and store these tokens in the word, some mapping table where will be the word and IDs of documents which correspond, and search through this table to find the original record with the full text of the string. And if you really need the full text search, there is also solution. We have the free open source IBC version full text UDR. It is available on the GitHub, or you can search for it also on firebird.sql.org, where you can implement and use full text search functionality, which is much wider than just a wildcard search, using the Lucene C++ engine. And it will be, of course, the most powerful and most fastest way to perform the full text search. Anti-pattern number 9 is not closing transactions for read-only operations. I was working with this document for quite some time, and I got some feedback for the early versions of document, and this specific anti-pattern, came after I created basic things in the previous anti-patterns, basic explanations why it is bad. But this one deserves the special explanation about the problem. So idea is the following. So many people think that if they are doing select operation, it does not require a transaction. You don't need a transaction, you don't need to start it or commit it, or you can start, but you can, skip the commit operation because it's just read-only, and Firebird will figure out that you did only selects, and after that it will just commit it or do some magic to avoid record versioning and so on. But unfortunately this is not so. The transaction to support read-only operations must be announced, must be created explicitly with read-only flag, and by default it is writable. It is with flag write. It means that when you are doing some select and you are not closing the transaction, so you do the last select with auto commit transaction, for example, automatic component or something like this, it means that you will generate the transaction which will be active, not closed, mark it as active until the end of this select, or very often until the end of the connection, until the application closing. And as a result, there will be a big portion of garbage versions will be created, because Firebird will maintain numerous back versions for the possible potential old snapshots. This is really often anti-pattern. It does not require you to do anything but use the default components, default behavior. So you just, created the T-query or created the query component in PHP or in Delphi, whatever. You are using the default transaction. You did select, loaded data in the grid, and that's all. In Delphi, for example, and you already entered this problem. So because it is only read select, you thought that it will not be a big problem because it's just a select. But unfortunately, Firebird will retain the old versions, which started for a long, which can be really long. So what is the solution? No, first of all, those who migrated to Firebird 4 and 5, it is much easier. So this problem is not a big problem anymore. However, for the explicit transaction management, it is a good idea to use read-only transactions and close writable transactions as soon as possible. So read-only can be really long. If you started the read-only transaction for read-only operation, which is the ideal situation. But if you did not use the special transaction read-only mode for your select operations, it means that Firebird will treat them as a normal writable transactions, and it will lead to all these things with old versions, garbage collection, and so on. From the DBA point of view, it is to maintain database in a good shape. It is necessary to implement proper sweep operations, proper garbage collection operations. And number 10, as we have discussed it in using like, many developers use like with embedded text of the parameters. For example, in this simple example, you can use something like select where name and put where the exact name of the exact value of the parameter for the name. What is the problem? What is the problem with this? First of all, it is bad because Firebird will require to prepare this query every time when it is started. You cannot prepare it with the parameters and use it many times. So will be prepare step. If the query is really frequent and tables where this parameter which I use it in the query are big, the preparation step can be pretty long, can be hundreds of milliseconds. And better prepare, of course. But if you are putting the parameter text into the query text, it will be not possible to use it several times, right? Also, of course, it complicates the analysis. If you're running Trace API and you are creating the performance report to see which queries were most often, consumed most of the time or most of the reads, fetched, and so on, due to the text in the parameters, it will just use another text and will be not grouped. There are several techniques how to work around it, but in general it complicates the thing. And least but not last, that embedding the text is an open door for SQL injections for the security vulnerabilities. So some hacker can create, if they will discover that you are using on some website or in some application these injections, this technique with the parameters, they can try to execute some bad code to harm the database, to manipulate the data and so on, as a part of parameters using some, techniques. And to avoid it, we just need to use parameters like this. So if we are using the parameters, these parameters will be strictly in the scope of the parameter, and it will be not possible to do the SQL injection, and it will be faster in case of multiple repetitive queries. Number 11. It's somebody could ask, is it for real? Somebody does not use the primary key to perform to guarantee the integrity of the database. But yes, it happens, and there are a group of people who believe that it is possible to use triggers or checks instead of primary key. But it is really bad pattern, and of course it is discussed in some university course like Databases 101. But anyway, we need to repeat it just to make sure that you always use the primary key. What is the problem with not using primary key? First of all, when you are creating some data, inserting new records, in order to guarantee that records will have different data, will be no duplicates, it is necessary to insert different data. When you are using the primary key, the Firebird use special mode to see all current record versions, and it will be not possible to insert duplicates, because this check is being performed on the lower level of Firebird engine. If you are using something like select if exists to check the existence of these in the parallel transactions, there could be some isolation level which prevents one transaction to see freshly inserted but not committed data from other transaction, and as a result there will be duplicates. So it is really necessary to use primary key. Also, if you are not using the primary key, it will just make the code more complex. You need to implement checks, triggers, and so on. You need to implement some duplicity checking for duplicates and so on. And the third, also a big problem, that replication, the native replication, will not work in Firebird 4, Firebird 5, and HQBird, all versions, without primary key or unique key for the table, because the replication engine will be not able to distinguish one record to another. So how to update or insert record if you don't know it's duplicate or not duplicate? So use primary key. Not so big, maybe not really big anti-pattern, but it exists, and that's why I decided to speak about it. Well, the solutions for this anti-pattern is pretty obvious. Use primary key or unique keys, avoid some redundancy checks, and keeps database logic simple. Well, as a general recommendation. So number 12 is also kind of related with this, but it happens more often. Maybe all of you, when you're young, I think the majority of people tried to do this, and the problem is the following: generation of IDs using the max. The code is the following. So if you have some table and you need to generate sequential IDs, and the first thought which comes to the mind, okay, let's use something, select max ID +1 from users, right? Why it is bad? If you are using this approach, it does not guarantee that there is no parallel transaction with the same code. And as a result, it will see the result of max the same with your transaction. And as a result, the max +1 in two parallel transactions will generate the same value. And with the same value, you will have the conflict if you are using the primary key from the previous example, of course. If you are not using the primary key from the anti-pattern 11, you will not have a problem with it. That also complicates the situation. So max +1 is not a good idea. How to implement it properly? Pretty easy. You should use generator or sequence, create generator, and after that retrieve the next value from the generator sequence. It can be directly in the insert or in the trigger. Generators works out of the scope of the transaction. So if you have retrieved the generator, it means that it will give you always the unique number, the next number. And even the transactions, parallel transactions with isolation level, which prevents you to see what is the latest value in the IDs, the generator will give you this value and will guarantee that the value is unique and the primary key will be created without a conflict. And continuing with primary keys, but not actually with keys, using of guide. So guide some time ago became really popular as a unique identifier, universal unique identifier. And the problem is here: if you are using the system-generated guide, which operating system gives you as a result of some call of API, and store it into the table, and you are using index for this guide, the index will be not so good. It will be pretty slow. Why? Because this guy is highly randomized, and it works much slower when the begin, or even much slower when the special guide, which generates currently by gen UUIT. So to work around it, use, instead of system generated guide, use gen UUIT. Better use begin or some kind of gradual data types like integer, begin, and so on. And in the Firebird 6, where will be implementation of UUIT version 7, which will be even better for the performance of indexes. And we are going to number 14. Number 14 is also kind of anti-pattern. The problem is the following. So you can create some table, and inside of the table you can unknown some field like computed by. And it is not prohibited to use query to other table from this computed by table. But it is pretty big in terms of performance and in terms of planning, in terms of maintenance of the database, and in terms of understanding what's going on with the business logic inside your database. If you are running it, it means that there will be a lot of queries from on the fly with every execution, every select for this table. There will be execution of this query. It is not cached. So if you executed 100 times, 100 times where will be this, query to our tables. And in our experience, when we see such queries, usually it is really difficult to optimize it. And so you can consider to, you should consider to do not use this logic because it's pretty bad. How to work around it? No, first of all, of course, you can create aggregates. So you can create some order, some trigger to update order total for this example or something like this. Yes, there could be problems with log conflicts in this situation, but also it is possible to resolve with some proper approaches, and it will be faster and easier in the future for maintain. Number 15, the final one. It, anti-pattern for sure, and it really annoying, and it's, really bad when you see something like this, when application just hides the original Firebird error, and it makes whole review all, horrible. It makes horrible all operations, debugging, migration, and so on. When you are just starting to do something and you are receiving, oh, this is some general Firebird error, but why it is error? Do you have some problem with the query, with parameter, with syntax, with new syntax, with migration, database is corrupted, Firebird server is not running, and so on. So it is really necessary to keep log of operations. Do not suppress. Of course, users does not like to see messages, something like Firebird error 001. They want to see something more. But for debug purposes, you should use login. You should use login and do not suppress errors without login. Pretty obvious, but it happens. And if we started to speak about anti-patterns, this is the real anti-pattern. So we have passed through these 15 Firebird anti-patterns, Firebird applications, anti-patterns, and I hope it was pretty useful. And what next? First of all, if you have noticed any error or something like this, please feel free to send a mail to me, to this email. Also, you can download the text summary of this presentation. It is in the description below. And also, I would like to invite you to become Firebird supporter. As you know, the Firebird database is a free open source database, but its development is not free, and Firebird Foundation is the organization which sponsors, which is financing Firebird database development. If you will become a Firebird supporter, it starts just from €10 per month. You will greatly help Firebird to evolve, to grow, and to bring new features to you and to all the community. And also very important, we are doing the special closed seminars only for the Firebird supporters. These seminars has real-time interactions with the Firebird developers, with me, and with some other knowledgeable guys in the Firebird community, which can answer you and where you can get some kind of consultation, or you will have access to the really good and really detailed information about Firebird functioning, about Firebird features, best practices, and so on. So, thank you for watching, and see you soon.